My name is Cody Rogers, and today we are going to go through the little schematic I've made for part one of learning the art of electric. It is just a simple power supply. I will first give a brief overview of this power supply. Let's zoom in here. We are going to be taking the power from a 120 AC voltage, like just the wall outlet of. Then we have a fuse here. So I did change this. If you look at the Learning the Art of Electronics on page 141 of Learning the Art of Electronics, actually has this very sort of exercise. I did a slight variation of it, mostly because to find a transformer that could do the 1 amp was very hard. Well, it wasn't hard. The transformers were expensive, so I decided to set it down to 100 milliamps. As I said here, I'm designing this for 100 milliamps regular supply, and then I said that can then test if the IRMS calculation in the LAOE is useful. Something. So they did a test to give some more context to that statement. They did a test where or like they calculated this IRMS, say that should be the current rating of the transformer, which I might end up blowing out my transformer because they said that it like the surge current on the capacitor would be 4.4 amps, which is 1 amp more than the output that they were designing for. So I'm designing it to be 10 volts, 100 milliamps out. So perhaps when we go to charge this capacitor, it's gonna blow this. So then let's just go continue moving over. I said with about a 60 milliamp slow blow fuse. So the calculation was here, and this is the same calculation that Learning the Art of Electronics did, but I just did it for a smaller amperage. And the first two is for surges, and the second two is so that it doesn't blow on off. Then I decided to go with the rectifier to save space on the board, and therefore money on this space. The four diodes and the rectifier actually were very similar in price. I think the diodes were slightly cheaper in volume, but I mean, the amount of space, since I would be using the hand solder like diodes, end up taking up room on my board. So to make the board simpler and smaller, I decided to go with the rectifier. That's the rectifier I chose right there. And it said the voltage drop is 1.1. So it said on its stated. So then over here, we went and we calculated the capacitance of the capacitor. So the delta T, which is the distant, like the discharge time for each ripple, said it was 8 milliseconds. Then we can calculate the capacitance using this equation found in Learning the Art of Electronics. C equals I delta T V R, where the VR is the ripple, which, so we got 0.1 amp times 8 milliseconds divided by, say, farads. Here's where we calculated the R bleed. I said 4.7 kilo ohm, and then I decided to add a indicator LED. Now that indicator LED, of course, has a small voltage drop, so I recalculated. It has a small voltage drop, and it has a turn on amperage. So I recalculated the value here and came to 3.6. This is I did. And then we connect it to the output. Now these pins here are all for test ports. So let's just move across the board here. So we got that speed terminal. Let's just go that guy there, 3.5 millimeters. Now this, you won't be able to see this now because I'm on the other screen. Let's go see what footprints are already in. These are 0.9 millimeter diameter pins, so they'll fit in there. Not very snug, but let's just go apply that same screw terminal over here.
Now, the fuse.
The top. I'll tell you the particular keypad of the fuse I chose. So it's a fuse glass 80 milliamps, so it's a bit higher than a 60 milliamps. Oh, you see, that's good. I checked this. So this, it's a fast flow fuse. We will actually have to go back and choose a new fuse because we want a slow blow fuse.
We need to first put in the manufacturer part number of the new fuse.
Okay. So now we need to choose a footprint for that one.
Okay, so now we got the fuse holder footprint. Now we have to find one for the transformer.
Now we have to go back to the list. Yeah.
So I had to create my own footprint for the transformer, and this little bit is me doing it, but it was mostly a mumbling mess, so I just really fast forwarded right through it.
Let's go do the pins now. So these are just the test board. See, I did pick out a breakable header connection. Okay, so it's 2.54. Go con. And now it's all done. I'm actually going to turn on my heat a little bit more. Okay, so next is this rectifier. Check it out. Footprint. Okay. I would have gone. Cancel, cancel. Let's go check out if I can find the footprint references, footprint libraries. Add a new one. Downloads. Documents. High-tech libraries. There it is. I didn't define football.
So basically here I was adding the footprint to the footprint library so that I could add it to the. What you will find out later is that those footprints were actually incorrect.
Say okay. So now let's go back and we will be able to find that one. So we've just used the footprint that I found when I downloaded that symbol. That's all. I think I forgot how to check the measurements of the footprints on while selecting them for the editor. Well, I don't know. I think it must have changed from KiCad 6 or 7 to KiCad 8 because I don't know how where my tape measure went there. But never fear, we will move on, and I will do it in the when we go to the PCB layout. Look at this. Okay, so now let's go here. This one is the capacitor. Capacitor I chose. Let's look. Of course it doesn't. Its diameter is 10 millimeters. The lead spacing is 5. So let's go here. Radial area. Diameter of 10. Pitch of 5. That one there. Now, let's go and look at this LED that I chose. I believe this just has red LED. Oddly, it's made by Broadcom. Let's go look at it. Case, radial. Doesn't really show me the size. There we go. So you see here we got the very nice. There we go. This one is 2.54 and 6. Let's go here. That LED. Let's go with this and just see what it measures as. Then for the resistor, I'm just gonna go with. It's way up here now because I thought I had this one right here is what I used. Now click OK. Now I better add both those to my cart. I think the next part is we'll save this. Then we'll go to the PCB layout. See if we forgot anybody. Oh. Now that we're here, I just want to check the sizing of things. So because that one, it's the measurements are just coming up a bit small on it, basically. Let's go with this one. Then we go back to our PCB. Update it. Close. Now, if that one's any better. Let's try the last one. I think this is the one we'll go with. So, now we have finally got our footprint. We're going to have to start the layout now. Let's go. So, I'm just going to place this transformer like that there. We'll move the fuse over. I'm going to just open up the schematic on another screen here so I can see what I'm doing here as I'm moving stuff around. Oops. To there. Let's look at it. What I think we can split this guy. Keep this guy closer. Can basically move this whole thing up. This will be just a rectangular board. That's why wouldn't you get a rectangular board? So I think the placement looks okay there. I'm gonna press the home button. Now, you can take some consideration with the nets here. And creep it.
So the next bit here is basically me spending 12 minutes trying to figure out how to make net classes work correctly so that I can make my 120 AC voltage higher or have wider track widths than the rest.
Well, I'm not sure what I'm doing wrong here, but it is not listening to me. So I am just going to continue doing the board layout and hope for the best. And we are basically done, it looks like. Cool. But, of course, you have to do we'll have to add some, what's it called? Silkscreen. In particular, I want to mark out the connection of these. Not that this side matters, but this side does matter because one's positive, one's negative. And then I also want to mark out what connectors both of these are. We'll do that. Just have a short bit here. I'm gonna go flip the coffee again. So I'm back now. It's been in for so long. Now let's go and label these. So we will go to our Silkscreen. Let's take a look at it. Let's see how long this board is going to be. Ooh, we're going to be almost 4 inches long. That could be a long board. Could probably be some over there at the AC connection, but I like having space between everything. Save. Let's do the rules checker.
I may have to get a bigger connector for the 120 AC connection. This section of video is basically me contemplating whether or not I should go to a bigger terminal for the AC connection.
Yeah, I think we might as well do that actually. So that means we have to go back to our. This is the new one. It's 5mm clearing instead of the which only half. Or 5mm pitch. Its clearance could be different, but it has a larger pitch, so that it should have higher clearance.
During this clip, I was basically going through and reassigning a footprint for the new wider pitch connector.
Okay, so now we have to redo these connections. As we remember, we had 2.5 because I can't figure out how to assign custom labels and net classes right now in the KiCad. Sorry, for some reason my garage is very cold right now. I did turn it up once. But you know me, I don't really like to spend money. So I don't want to turn it up again. So it has one warning. Which is that board has malformed outline. There, which I haven't done it yet.
So in this part, I was just checking the DRC again, and I got to the point where it was only saying it had a malformed outline, which it does because I hadn't added a board outline yet.
Let's go back and we'll make this. I'm just gonna make the outline now, so here. Oops. Better do that in edge.cuts. It's right there. There we go.
Let's run the DRC.
One warning, does not match. Basically everything is good. I'm gonna take a picture of this. PCB be way over here. Yep, that looks like it's good. I will be posting these files on GitHub somewhere. And when I do, the link will be in the description of the YouTube video. Well, thank you for watching this video. I hope you check out the next video, which will be me assembling and testing this circuit to see if I actually did it right. If I didn't do it right, then it will be a description of what was wrong with the PCB. Thank you for tuning in, and I hope you enjoyed it.